All right, this lesson is on sigma notation and repeating decimals. Sigma notation is used to indicate a sum or a series. Sigma is a Greek symbol, looks similar to an E. The equation below the sigma is referring to the starting value of n. The variable or constant above sigma is the maximum value of n. And then the expression in front of the sigma, that's the expression for each term in the sequence. All right, so for this first example, we're going to rewrite as a sum. Simplest way to do this is to just replace the k in the expression with 1, and then 2, and then 3, and so forth. So when we replace the k with a 1 and simplify the expression, we get 19. When we replace it with a 2, we get 16, all the way down to replacing the k with a 6, and we get negative 16. Now we want to evaluate this summation. So the first thing we're going to do is determine what A1 is. A1 is, once we plug in plug in 1 for n, 1 minus 2 is negative 1, and negative 1 times 1 is negative 1. 2 is going to give us 0. When we plug in 2 for n, 2 minus 2 is 0, and 0 times anything is 0. 3, the third term in the sequence is going to be 3. Fourth term is 8. Fifth term is 15. Sixth term is 24. So when we add the first 3 terms, we get 2. When we add the last 3 terms, we get 47. And for a total of 49 for the value of the series. Next, we want to rewrite this expanded notation. We want to write it using sigma notation. So start with the sigma, and we have to determine what our starting point is. You could start it off with 500. I think that it makes more sense, though, to look at the difference between each one of the terms, and you can see that each term is being, you're adding 1 to each one of the terms. So rather than let n equal 500, and actually, you want to let the first value of n be 0. And so if the first value of n is 0, so 0 would represent the first term, which is 500. Next term, 501. So we're going to count from 0 all the way up to 3. So 3 should be above the sigma. And then as far as trying to determine the expression, we already said that our first value of n was 0. So what do we need to add to 0 to get 500, the first term in our sequence? And that would be 500. So we have our expression. So 0, which is the value of n, plus 500. So whenever n equals 1, you have 1 plus 500. When n equals 2, 2 plus 500, and so forth. And then lastly, you should be able to write a repeating decimal as a fraction. So we've got this decimal, 0.370, repeating. First thing you want to do is write out that portion of the repeating decimal. So the 0 in 370 is in the thousandths place, so that is 370 thousandths. And then after that, the you would write 30, you would have 370 again, and that second 0 is going to actually be in the 1 millionth, 1 millionth place. So if we add 370 over 1,000 plus 370 over a million, we would just have the 0.370, 370. All right, so we're gonna just keep that going, and that process, that pattern would just repeat. It would still be 370 in the numerator, and you would keep adding 3 zeros in the denominator because the group of numbers that's being repeated has 3 digits in it. So we can see now in this sequence that the first term is 370 over 1,000. And to get the next term in the sequence, the numerator is the same. We're just multiplying, we're adding 3 zeros to the denominator, or multiplying each of the preceding terms by 1 over 1,000. So now we just plug it into our series formula for the value of a geometric series. We have 370 over 1,000 for a sub 1, and then 1 over 1,000 for r. 1 minus 1,000 is 999 over 1,000. And dividing 370 over 1,000 by 999 over 1,000 is the same thing as multiplying it by the reciprocal. The thousands will cancel, leaving us with 370 over 999. That can be simplified. 37 divides into 370 10 times, and 37 divides into 999 27 times.